In simple terms, a penetrator space probe is a type of spacecraft that can penetrate the surface of a celestial body, such as a planet, comet, or asteroid, and survive the impact in order to explore the interior of that celestial body. The term penetrator is sometimes used more broadly to refer to other types of space probes that are designed to study the surface or atmosphere of a celestial body but are not necessarily required to penetrate the surface. For example, the Viking landers that explored the surface of Mars in the 1970s were sometimes referred to as penetrators. Despite not having the ability to penetrate the planet's surface, penetrator space probes have been designed to enter the surface of a body such as a comet, survive an impact of hundreds of Gs, measuring and telemetering the properties of the penetrated surface. Penetrator data would typically be telemetered to an orbiter craft for retransmission to Earth. As of January 2013, only a small number of penetrator missions have been attempted. The Comet Rendezvous Asteroid Flyby CRAF mission included a cometary penetrator, but the mission was cancelled in 1992 due to budget constraints. The twin Deep Space 2 penetrators, which piggybacked to Mars aboard the Mars Polar Lander, succeeded in striking the Martian soil on December 3, 1999. Unfortunately, no data was transmitted. Our prime example of a penetrator spacecraft is the Deep Impact Spacecraft, which was launched on January 12, 2005. Targeting the Comet 9P Temple, Deep Impact's impactor module successfully collided with the comet's nucleus, releasing a plume that was observed by the spacecraft itself. Since we have already talked about the definition and some examples of penetrator spacecraft, now let's talk about some of the famous missions that have been conducted using this technology. One of the most famous missions that use penetrator spacecraft is the Deep Impact mission to a comet. The Deep Impact mission was a NASA Discovery program mission launched in 2005 to study the debris ejected from a comet when it is struck by a spacecraft. It was the first mission in history to smash a spacecraft into a comet. The mission consisted of two parts, an orbiter and an impactor. The orbiter studied the comet before and after the impact, while the impactor was designed to smash into the comet at 14 miles per second, 22 kilometers per second. The main goal of the Deep Impact mission was to determine what kind of material is found beneath the surface of a comet. Scientists believed that this would give them clues about the composition of the early solar system and the origin of life on Earth. Before the impact, the orbiter took images and measurements of the surface of the comet, and then followed the impactor as it descended towards the comet. After the impact, the orbiter continued to take images and measurements of the debris cloud that was created by the impact. The results of the Deep Impact mission were published in 2006, and they showed that the material that is found beneath the surface of a comet is similar to the material that is found in meteorites that have fallen to Earth. This suggests that comets could have played a role in the delivery of water and organic molecules to Earth in the early solar system. Another mission that has been conducted using penetrator spacecraft is the IcePick mission to Europa. The IcePick mission was a joint US-Canadian mission to Jupiter's moon Europa. The mission was designed to study the moon's atmosphere, surface, and interior. The spacecraft was equipped with a penetrator probe that was designed to penetrate the icy surface of Europa and study its subsurface ocean. Unfortunately, the IcePick spacecraft was lost during its approach to Europa in 2000, and the mission was never completed. However, the data that was collected by the spacecraft before it was lost provided valuable insights into the moon's atmosphere and surface. The third mission that has been conducted using penetrator spacecraft is the Luna mission to Earth's moon. The Lunora mission was a Soviet Union mission to the moon. The mission was designed to study the moon's atmosphere, surface, and interior. The spacecraft was equipped with a penetrator probe that was designed to penetrate the lunar surface and study its subsurface structure. The Luna 9 probe landed on the moon in 1966 and transmitted data for several days before going out of range. The data that was collected by the probe provided valuable insights into the moon's surface and interior. Now, let's discuss how these penetrator spacecraft work. A penetrator spacecraft typically consists of a main spacecraft and one or more penetrator probes. The main spacecraft carries the penetrator probes to their target and provides power and communications to the probes. The penetrator probes are carried on the main spacecraft until they reach the target. Once the target is in sight, the penetrator probes are released from the main spacecraft and begin their descent towards the surface of the celestial body. As the penetrator probe approaches the surface, it uses a combination of parachutes and rockets to slow down and control its descent. The probe is equipped with a variety of instruments that are used to measure and collect data about the surface of the celestial body. These instruments may include cameras, spectrometers, and other scientific instruments. The penetrator probe is also equipped with a communication system that allows it to transmit data back to the main spacecraft. As the probe approaches the surface, the communications system switches over to a higher gain antenna to allow for more precise tracking of the probe. Once the probe is close enough to the surface, the scientific instruments are activated and begin collecting data. The probe then penetrates the surface of the celestial body and comes to rest either on the surface or just below the surface. The scientific instruments continue to collect data as the probe is buried in the surface. The communication system continues to transmit data back to the main spacecraft until the probe's batteries die or it loses contact with the main spacecraft. The main spacecraft continues to orbit the celestial body and collects data about the atmosphere and surface of the body. It also receives data from the penetrator probes until they stop transmitting. The main spacecraft then transmits all of the data it has collected back to Earth. There are many challenges associated with sending a penetrator spacecraft to a celestial body. One of the main challenges is designing a spacecraft that can withstand the extreme conditions that the spacecraft will be exposed to when it enters the atmosphere of the celestial body. The spacecraft must be able to withstand the heat generated by atmospheric friction, as well as the impact with the surface of the body. Another challenge is ensuring that the spacecraft can land accurately on the surface of the celestial body. The spacecraft must be able to control its descent in order to land in a specific area of interest. Additionally, the spacecraft must be able to communicate with the main spacecraft and transmit data back to Earth. This can be challenging due to the distance between the two spacecraft and the limited amount of power available to the penetrator probe. Penetrator spacecraft are typically used to explore planets, comets, and asteroids. They are often used in missions that require the spacecraft to land on the surface of a celestial body and collect data about the surface. Penetrator spacecraft have been used in several famous missions, including the Deep Impact mission to a comet and the Magellan mission to Venus. That's all for today. I hope you liked this video. If you really did, then please like this video and share this video. Also, don't forget to subscribe to our channel so that you will never miss any new updates from us. Thanks for watching.